So what we're going to be talking about in Unit 8 is the behavior of solutions. Somebody want to tap Jonathan over there? Wake him up? Okay. Now, there's a lot of terminology and theory that we can learn later, but there's a couple things that you do need to know right now about, in terms of the terminology having to do with solutions. One of them, solutions are made of two parts. I say one of the two of them. I'm going to define solutions and the two parts of a solution for you. So solutions are made of two or more substances mixed together where the particles, so we just finished a unit on structural particles that we're talking about here. Structural particles are a nanometer diameter or smaller. Two or more substances mixed together where the particles are a nanometer diameter or smaller. How small is a nanometer? 1 billionth. Okay, everybody knows how long a meter is? It's a little more than 3 feet. What? 100 centimeters. Okay, and so the little tiny markings. Huh?
I was thinking of a meter now.
A meter.
I'm thinking of a yard. Yeah, I was thinking of a yard.
A yard is 3 feet.
Yeah.
But we don't want to use feet because that's a nasty word in chemistry. Okay, we want to talk about meters. We only use the meter system, the metric system in the sciences. All right, so this is of course just a little tiny part of a meter. Each of these little tiny markings in here, the 1 to 2 range here, this little range right here, that's a centimeter. The little tiny markings are millimeters. The little tiny markings are millimeters. Hello? Okay? Sure. Rachel, you need to go by attendance when you leave here. So this little tiny marking here is 1,000th, okay, 1 over 1,000 of a meter. All right, Rachel, if we split each of those little tiny marking sizes into 1,000 part pieces, okay, split them into 1,000 pieces, then split those into 1,000 pieces, and then split those into 1,000 pieces, then we have a nanometer. Okay? So, well, I'm sorry, that's the math for the meter. So this split into 1,000, that split into 1,000, that's a nanometer. Okay? Basically, 10 nanometers is roughly the size of an atom. Okay? I'm sorry, 1/10 of a nanometer is roughly the size of an atom. So we're talking about really, 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 really small things. When we talk about a homogeneous mixture, you remember talking about homogeneous mixtures in physical science? Okay? Homogeneous mixtures. And the definition of a homogeneous mixture in physical science was probably something that was the same throughout. To a chemist, it's not the same throughout unless the particles are a nanometer diameter or smaller. So the only true solution is a The only true homogeneous mixture for a chemist is a solution. Okay? All right, now a solution is made of two parts. It's made of the solute. Okay, the solute is the thing that gets dissolved. And then you have the solvent. And you can say that's the part of the solution that does the dissolving. So we're going to learn about 3 ways of determining, measuring, if you will, concentration of solutions. So concentration, in general, we could say is how much solute is dissolved. And the solvent or solution. You got a lot dissolved, that's a higher concentration. You got a little bit dissolved, that's a lower concentration. Okay? All right, we'll pick up from here on Monday.